Hello Year 11s and welcome to our second lesson in this Biomechanics Flipped Classroom series of lessons. So today's biomechanical principle that we'll focus on is force summation. When learning about force summation, there are three things that you need to understand. Firstly, that the definition is basically that it is the sum of all forces. Secondly, that it's all to do with the order that the muscles are used, and thirdly, it's to do with the timing in terms of the muscles. So let's have a look at these in a little bit more depth. So firstly, if you have a look at the sum that we have up the top there, we have 1 plus 1 plus 1 plus 1, which, as you all know, equals 4. The 4, in this situation, this maths example, is the sum. So the 4 is the sum. And 1 plus 1 plus 1 plus 1, those 4 individual ones, those are the parts that make up the sum. Now, if we apply this to the principle of force summation, it's very similar. The different parts that we have that make up the sum are, in this example below, we've got leg muscles, we've got hip muscles, shoulder muscles, arm muscles, and wrist muscles. So we've got 5 different muscle groups, and together they equal force summation. Now, the more muscle groups that you have, the greater the force that is going to be able to be created, therefore the greater the force summation overall, as with the maths example above. Okay, so to remember, that first point is that force summation is all to do with the sum of all forces that is created in the muscles. So that's the first thing for you to remember. Let's now have a look at order. So here we have order. The first thing to consider is this bit that's down the bottom, and that is that in terms of the muscles, when we're thinking order, you think the big muscles first through to the smallest muscles. So in this example here, the biggest muscles, which are the first ones that are used when thinking order, are the legs, as they're the biggest muscle group, followed by the torso, the shoulders, then working down the arms, the hands, and the fingers. Now, this is in the example of a tennis ball throw, so a throw of a tennis ball. So of course in that, the things that are important, firstly your legs, torso, shoulders, arms, hands, and then lastly your fingers. And that is the ideal order when thinking about the big muscle groups through to the small muscle groups when throwing a tennis ball and trying to create the greatest force summation. So that second point there was order. Okay, so the last thing to think about is timing. So timing. And we'll have a look at this middle example here first because this is the ideal situation. This is the well-timed example. And as you can see here, the legs are the first muscle group to be utilized. So at the beginning point here, this is when the force is being created or generated, and it comes up here. And at this point here, the top of the parabola, the top of the curve, before it starts to go down, that is when the greatest force is generated. And as you can see, at this point, that is when the hips take over. And once again, at the top point there, the shoulder, followed by the elbow, and followed by the wrist. Now this example is in a shot put throw. Okay, so you can see similar muscle groups, or the same muscle groups are used as they were in the tennis ball throw. So that's well timed, that's ideal, that's what we're looking at. And you can see if you come across here to the left hand side, the amount of force that is generated is really quite high. Now on the left here we've got too early, and you can see the result of too early straight away. You can see the force that is created is much less than the well-timed version. So if you have a look here, this is when the force is beginning to be generated or created, comes up, it hasn't got up to its maximum. So its maximum's up here, it hasn't got to that point of the legs, but the hips have come into play. And the same thing happens with the shoulder, the elbow, and the wrist. And the result being not the same amount of force has been created, much less. Same situation when it's too late. So force is being generated, it's got to its maximum, it started to decelerate or drop off, and then the hips come into play. Same with the shoulder, the elbow, and the wrist. And if you look across here, if it's too late, even less force has been generated. So the optimum, the ideal situation is to be well timed, as this middle example is here. Okay, so let's have a look at an example. So here we have Valerie Adams, as you all know, fantastic shot putter. Being an Olympic and world champion, she most definitely applies the biomechanical principle of force summation. So let's have a look at the left-hand picture here. This is when she's getting ready, the preparation kind of phase before she starts before the throw. So as you can see here, the knee is flexed, and the knee being flexed, that's the hamstring muscles, as you know, that are the agonist in this position, but as she moves across, she will flex and extend her knees. So both the hamstrings and the quadricep muscles are involved, being in the leg, so those are the ones that are used initially. And as she goes backwards across the circle towards the front of the circle, it's those leg muscles that are used, and also those hip muscles, those bigger ones. If you look at the picture on the right, this is towards the end of her throw, but you can see obviously the legs have been used, followed by the hips, then the shoulder. You've got the elbow here, which is currently flexed, but it is extending. And the last one, the smallest muscle group, the wrist. And lastly, as she throws it, there will be a slight flick of the fingers as well. So that being the smallest muscle group, the fingers. So we've got the legs and the hips, then we've got the shoulder, elbow, wrist, and fingers. And that is a practical example of force summation. So the key things to remember, once again, is first of all that force summation is the sum of all forces that is generated and created by the muscles. Secondly, that the order is important, order being the biggest muscles through to the smallest muscles. And lastly, the timing, making sure that you are getting the maximum force generated from each muscle group. One last thing to think about is that force summation is actually something that we do naturally when we play sport, or we throw a shot put or a ball or a discus or a javelin, for example. We don't actually tell our body which muscles to use, it just happens naturally. Have a look at the worksheet that goes with this and see if you can answer the questions. If you have any questions, feel free to ask me either here or in class, and we will do a practical application of this next lesson. So thank you for listening, and that's all for today.